Okay, this is the 2017 CCO editorial, and this is my third time recording this because I was a dumbass. But let's go. Okay, question 1. So this question is asking you to create a graph such that there are k pairs that A is smaller than B, and you can go from A to B back to A without hiking on the same trail. And given the k, you're trying to find any graph. You're just trying to create the graph. So for this question, if you see go A to B back to A without any loops, that kind of gives you the sense that you want to create a cycle, right? So if you create a cycle, that brings the question, how many beautiful pairs are in that cycle? And basically, suppose there was only three nodes in this cycle, then this 1 can go to 2, 1 can go to 3, 2 can go to 3. 4, 1 can go to 2, blah, 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 boom. So y'all did math before, and this is just a calculation, right? You can calculate. You can just straight up calculate it with this formula, right? So now you know that. So it's optimal to make the biggest cycle possible without going over the limit of k beautiful pairs every single time. Since why would you create smaller ones when you can create bigger ones? So you just do it so you find this n by using binary search. And yeah, that's basically it for this question. Oh my god, I was about to forget again. Okay, here's the code. So you get the n, you binary search that, and then you just keep going. You just add, and then you add the shit into the answer. And the binary search is the mid times mid minus 1 divided by 2. Yes, sir. And then boom, you're done. Pretty simple, pretty easy. Okay, this question, Cartesian conquest. Y'all can go read the edit or the problem statement. I'm not gonna explain shit because I'm tired. Okay, the rectangle. You got this gap down rectangle, and you're trying to go from this rectangle to nothing, right? And each time you can only take a 2x1 rectangle out of it. You can only minus a 2x1 rectangle. So you can either do this, you get rid of this dude, get rid of this way, this way, this way. Okay, I'm gonna show you the 3 ways you can do this. So n times m triangle, or fuck triangle, rectangle, is the same as m times n, right? So you can just flip it. So let's just make n smaller than m always, yeah? It's the same thing. So if n is always smaller than m, how many ways can you take away from this bitch? Well, one way, you take away here. This will be n, this will be n divided by 2. That's one way you can do it. What's the second way? N, this is n times 2. Okay? Or you can get rid of it like this. This is m divided by 2. That's the only 3 ways you can fuck with this. So now that you know that, you can solve the first subtask by just straight up brute forcing every single possibility. Now that's clearly not optimal, right? So then what? Then you can think about this question greedily, right? Okay, wait, y'all didn't even see what was going on, but it's fine. I didn't even do shit. Okay, then you can use so this question is asking what's the minimum and what's the maximum. So for minimum, okay, for minimum, if the current state is this is m. And if m divided by 2 is bigger than n, if m divided by 2 is supposedly bigger than n, then the only operations you can do is n divided by 2. Oh fuck, n divided by 2. The only operations you can do is this one and this one. You can only do these two operations if m divided by 2 is bigger than n. So in that case, you can only do these two operations. If you're trying to find minimum, of course you should do n divided by 2. If you're trying to find maximum, or I got it wrong. If you're trying to find minimum, of course you're trying to do n divided by 2. If you're trying to find maximum, you would want to do n times. I got it wrong again. Okay, just get it. You understand the idea, right? Okay, I'm just gonna hope y'all understand the idea. Honestly, this question, I didn't even pass the Moj, but I got through on the actual CCO. What the fuck am I writing? Okay, NM, let's find minimum. Also, you use a map to store DP, whatever. Swap it, boom, boom. If it's 0, return 0. If it's both odd, you can't do shit. If it's there, it's there. Solution. If n times 4 is smaller than m, this is find minimum, so this is like cutting it. Boom, 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 boom. You cut that shit. And if m percent 2, boom, boom, boom. Yeah, you gotta just think about this yourself, bro. And for maximum, it's the same thing, but you would take the bigger jumps or smaller jumps, yeah, whatever. You do the same thing. Yeah, it's basically this question. Okay. Okay, still good. Okay, I love discussion. Discussion's a fucking fun one, dude. Discussion's a fucking fun one. Okay, so you're on an infinite 2D plane, right? And you're given these coordinates, and Vera would add a paint drop of color or of value v to all points that in the form of x plus ai, y plus bq, or q are non-negative integers, right? And it's querying the sum of the values at a single random point. Okay, Ben, this is a lot of bullshit. What is going on? Well, there is a lot of bullshit, but we'll make it clear. Yeah, so let's take the orange drop, for example. Orange drop is at 6 and 3. Starts here, right? If it's here, then, okay, let's consider x first. So 3. What B and Q are, or A and B are the largest power to not greater than x, which in binary is its highest bit. So it keeps adding its highest bit. Look, 3. Is that x? Okay, 3. It keeps adding its highest bit, which is 2. Jumps to 5, jumps to 7, jumps to 9. Okay, it's at 6. What is its highest bit? Its highest bit is 4. It keeps jumping 4. Boom, boom, boom. So now, think of what x values are painted by this orange thing. Or instead, yeah, think of what x values are painted by this orange thing. Orange. Block. block. So all of the x values are, yeah, so it's 6. It keeps adding this 4. It keeps adding this 4. It keeps adding this 4. Okay, that doesn't pattern. I don't know what the fuck is the pattern. Okay, how about we think of this question in binary? So look, that orange shit, that x value was 6, right? Its x value was 6. What is that in binary? Oh fuck, what is that in binary? 110, I think. This one, this one, this 2, this 4. Yeah, it's 110. Yeah, you get me? So every single time, so all x values. So it starts at 110. Then it keeps adding this 1. It keeps adding, keeps adding, keeps adding. Then it'd be like 1010. And then 1110. And it keeps going. Like 11110. Like blah 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 blah. Every single thing could be there. And it will be there. 10. So if a number has this prefix of 10, or no, the suffix of 10, that means it doesn't matter whatever this shit is over there, it will get hit by the orange drop on the x-axis at least. It will get hit by this orange drop since it keeps adding this value. It keeps adding. No, never mind. It keeps adding this value. Then it could 1 0 0 blah blah blah. It keeps adding that shit. So anything after that is possible. But it has to have this suffix. Okay? So when you're querying, right? When you get hit by a query, you can go. Okay, I'm going too far first. Alright. So what is an algorithm that keeps track of suffixes or prefixes? Think of an algorithm that can keep track of many different prefixes. Try. Now, that's actually crazy. Okay, so you go down to try, and if it matches with this shit, then you get added, right? No, but okay, this is supposing it was only the x-axis, but now we're on 2 dimensions. So we also have to consider the y. So from every x-axis, once you get the suffix, then you can go. Let me draw out a try. So this is the start node. You go here. This is the 1, and this is the 0, right? Then you can link this to another goddamn try. So this is tries on tries. Now we're on another try. Now this is the y value. Okay. So this is the y value. And let me take a look. So for the orange shot, that y value was 3. So let's write 3 in binary. 1 1. As highest bit is this 1. So the suffix is 1. This is the suffix. If it has the suffix, then you're good. So if this guy, and then you go down, you go to a 1 or something. So if you're querying a certain number, you can go down here, and for this node, you can go search for its y, and you go down here, and at the end, this stores v, the amount. So I don't know if that is super clear, but yeah, I'll just show you the code. Fuck. I was on a roll, bro. I was feeling myself. Where's the real code? Okay, let's start. NQ X Y V, right? And you insert. And this is the try, right? So you're given the X value, you're given the starting point, and you're given the V value. Okay. We get LX, which is the highest bit of X. And for every bit under that, we create a try. And this is standard try shit. This is the standard try creating shit. And then this this creates an endpoint. And this endpoint links to another, this is a double layered try. This endpoint links to a double layered try. If this is X, this endpoint leads to the Y try, linked off that point. Honestly, I have no idea how would you think of this in context, unless you've seen this kind of question before. But yeah. And then this endpoint just added, and you insert once for the X value, insert once for the Y value, and then you query. Let's look at the query. Get the most significant bit for X and Y. P equals edu. What the fuck did that do? Okay, so for every X value, you can you can query down the Y value, since every X value might have a query like a linked tree of Y besides it. So if there's a linked tree of Y, then you go down to Y as well. You add that shit up. This is normal try shit. Normal try shit. Okay. That's basically this question. Honestly, this is crazy. I think other people did it through like some shit. They did it through something like Fenwick tree, but I don't really know how that works. There's some Fenwick tree shit. I don't really know how it works. I think the try explanation is the simplest. Yeah. And I think it's not even that slow. 12.29. Yeah. Speed is fine. Ask me. This question. Fuck. Dude, all of these questions are not hard algorithmically, but hard on thinking. Like, these questions are, you gotta ponder for a bit. Okay. You have pillars of various heights, and rain can fall down and get stuck in the pillars. Okay. Rain can fall down, you can get stuck during the pillars. Yeah. Dude, okay, wait, shit. I'm kind of getting stuck. Wait, give me like, yo, if you're watching the video, skip past for a little bit, because I'm doing a little pondering. Okay, I'm back. I just did a little pondering, but it's all good. Okay, so for all possible configurations of this shit, what are all the possible obtainable volumes of water? At first glance, this shit seems kind of impossible. Like, how the fuck are you supposed to get all possible configurations? How? But the crux to this problem is you make an observation. And the observation is how do I even make this observation? I don't know. Some shit has to click in your brain, and you make this observation that if you go from the highest type, yeah, motherfuckers, yeah, since keep adding it, go monotonically down. Yeah, I had an observation. Yeah, so is that before? Yeah. This was a brute force code. Okay. Yeah. So the observation here is if you go monotonically, if you sort the heights of the pillars from biggest to smallest, right? Then every single time you add a pillar. Okay, first you got your biggest pillar. Then every single time you add a pillar, it can either do nothing, right? Or go between. Do nothing or go between. Do nothing or go between. Okay, that's 3 pillars. Now imagine we had 4. Okay, this is even smaller now. Do not go between, go between. So each time, and it doesn't matter, and this doesn't matter how the pillars are placed. That's the important part. It doesn't matter how the pillars are placed, since each pillar is bigger than that shit. Each pillar is bigger than them. Wait, fuck. I'm explaining this horribly, bro. If it was something like this, if you already placed it like here, then you're adding an even smaller one right now. You place it here. Wait, shit. Is this correct? Why can every single guy do this? The crux of this shit is that every single guy can do this. Do these. But why? Yo, if you're watching it, skip forward a little bit. Wait, no, it works. Yeah, it works. Yeah, it works. Yeah, it works. It works. It goddamn works. Yes. The water line. Dude, it's the fucking water line. Okay. Yeah, it's the fucking water line. Every single time you can add the newest guy to any other guy and have that difference as the amount of water above his dumbass. Dumbass. Okay, let's just look at the code. Fuck. Okay. So we use bitset because that's faster. Seeing it? Sort that shit. And first we mark 0 as correct. And then we start at 2 because we can't fucking like compare ourselves to 1 because 1's the GOAT. And then we store DP into O. And then for every single distinct value that we had before, we can all of these values moved up by x minus AI, which is the difference between that value, the AI, between that water line and him. That's the amount we can move up by. And it's or this is bit set or and it or it and it 鱼等于 and then insert it. And then boom. The water line. Okay. Trust the process. Okay, whatever. Ay. This question is kind of a disaster. So this guy's trying to connect with N motherfuckers. And a guy's willing to connect with them if he has at least AI connections with the community already, or if he gives them B internet points. Very nice. Very nice. Very nice. And he does not want to give away his internet points, so he wants to blah 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 blah. He wants, yeah. So for this question, like a common pit trap would be just to buy the cheapest dudes. The problem with that is this sample 3. So this guy, you already got him ass, but if you buy him, then you still have to buy his ass. So it's better to buy his ass and not buy his ass, right? So what's going on here? That doesn't really make sense, right? So there's 2 ways we can approach this problem, and we can solve it 2 ways. I'll talk about the first way first. So for this problem, you can either think about it as who will you not buy? Which motherfuckers will you not buy? So you can sort this based off its A value, which is the number of people it needs to be friends with first. And then you can choose people to not buy. Okay. I don't really understand this greedy, bro. Fuck, dude. Okay, let's approach it from the other method. Because I don't really understand this method of greedy. So shit. Let's approach it from the other method. Which is thinking about who will I have to buy. No, the other method, motherfucker, the other method is still who can I not buy. Right? This method is who can I not buy. And fuck this greedy. How the fuck y'all shitters even think of this, bro? God damn, I'm getting mad as fuck. So you got these in values, you got these goddamn values. And so you have n people you want to make friends with, and each person's maximum motherfucker is only n. So of course you don't want to pay for the most expensive dudes. So let's place the most expensive dudes first, right? If there's the most expensive dude, that place want to get at 2 first. Okay, we'll get his ass at 2. Okay, then this is the most expensive dude that will get his ass at 1. Okay, we'll get his ass at 1. Then what if there's another dude that wants 2? But here, if there's 2 guys, he's good. But there's already a guy at 2 guys, and we can't allow that shit. So we put him at 3 guys. But if he moves to 5 guys, then we have to buy his ass. Okay, honestly, fuck. Let's look at the code. I'll think about this later. And fuck me, dude. This is the DSU. You insert. You do the DSU bullshit. Boom, boom, boom. You go buy the most expensive first, and then you buy the ass out. If they're n, you add his ass up, and then you merge it. Otherwise, you can use a priority queue and then add it, and then this is which guys you won't buy, and then boom, 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 yeah. Fuck. Or you can boom, boom. Okay. I'm sorry. I'll make the next editorial better. I'm sorry. This question I didn't even fucking do, bro. I was too fucking tired. But I'm gonna tell you how to do it, and you can do it yourself. This homework. This is your fucking homework, right? So you can move by shift operations to get 100% on this question. You have to do something like Rubik's cubes. Let me see if I still have the file. Yeah, it's like Rubik's cube. Just fuck it. Just find Rubik's cubes. Fuck you guys.